queries returned 0 rows because a delete without a where clause removed all rows from the sales table. Welcome to Snowflake SQL. In this lesson, you'll learn how to query, filter, join, and use window functions in Snowflake with production-ready examples and common pitfalls. Covers what you need. Snowflake SQL is a dialect of SQL used in the Snowflake data warehouse. From your browser, queries go through business logic to the database. It extends standard SQL with time travel, zero-copy cloning, and semi-structured data support, optimized for large-scale analytics. Think of it as a super-powered library where data is stored in a magical way that makes finding any book incredibly fast. In step 1, you write your query. Snowflake's select statement follows standard SQL but includes powerful extensions. Always specify columns to reduce I/O and use limit to preview your result set. Avoid select in production. It reads all columns even if you don't need them, though in step 2, columnar storage makes it efficient when you truly do. Finally, step 4 is about monitoring performance. Check clustering with system $clustering information. Here's a basic select query that retrieves specific columns and limits the results to 10 rows. This is a safe way to explore your data without scanning the entire table. Filtering a query in Snowflake uses the standard where clause. Micro-partition pruning automatically skips irrelevant partitions based on your filter conditions. For optimal performance, filter on clustering key columns and use explain to verify pruning works. This query filters orders within a date range and only includes orders over $100. Notice the use of between and a comparison operator. In production, use explain to see if partition pruning is happening. Wrapping a filter column in a function like dateTrunc prevents Snowflake from using micro-partition pruning, causing a full table scan. Instead, use a range condition like order date between 2020-40101 and 2020-40131 that allows pruning on the raw column, keeping scans minimal. Snowflake supports all standard join types, plus lateral and ASOF joins for more complex row-based and time series matching. When joining a customer's table with orders, ensure join columns are of the same data type to avoid implicit casts. The query optimizer automatically chooses the join order and algorithm. This query joins customers and orders, then aggregates to find total spending per customer. Note the join condition and the where clause filtering on the order date. Joining on columns with different data types forces Snowflake to perform implicit casts, slowing down the query. The fix is to explicitly cast the string column to int with int, so both join keys are the same type and the join runs efficiently. Window functions like row number, rank, and dense rank operate across partitions defined by partition by, then order by orders rows within each partition. These calculations are essential for analytical queries, and Snowflake supports all standard window functions plus qualify to filter after the window step. This query ranks customers by monthly total spending, using dateTrunc to group orders by month and rank with partition by month. The qualify clause then filters to only the top 3 per month, avoiding a subquery. The mistake here is omitting the frame clause, leaving SQL to choose a default that may not give the expected running total. The fix adds rows between unbounded preceding and current row to explicitly define the window from the start to the current row, ensuring the correct cumulative sum. Aggregate functions like sum and AVG can be used with over to compute running totals, such as daily sales and moving averages. The frame clause defines which rows to include. For large datasets, consider warehouse memory. This query computes a 7-day moving average of daily sales. The inner subquery aggregates sales by day, and the outer query applies the window function with a frame of 6 preceding rows and the current row. Starting from your current table, Snowflake's time travel lets you query the historical state of your data up to 90 days back. Use AT or before with a timestamp, offset, or query ID. Zero-copy cloning creates a copy of a table without duplicating data, perfect for testing and backups. The first query uses time travel to see the orders table as it was 1 hour ago. The second command creates a zero-copy clone of the orders table for development purposes. This is the chain reaction that unfolded. A developer ran a delete statement without a where clause, removing all rows from the sales table. Users immediately reported missing sales records for the last quarter. The developer assumed the data was permanently lost because the delete had been committed. The fix was to use Snowflake's time travel feature. By running create or replace table sales clone sales AT, timestamp equals 2020-40-115-10, 0000, timestamp, the table was restored to its state before the deletion. Data was recovered instantly, resolving the incident and demonstrates the value of time travel. This is the exact mistake from the incident. A delete without a where clause removes every row in the table. The fix, shown here, adds a where clause to restrict deletion, for example, to rows before January 1, 2023. Always test your delete with a select first, and use transactions to guard against accidental data loss. To diagnose issues, check the query profile for full scans versus micro-partition pruning. Use explain to see the query plan. For join problems, verify join keys and data types. For time travel, check the retention period. Let's walk through common Snowflake SQL interview questions. The ranking functions, time travel with its 90-day retention, and using window functions for top-end queries. Let's review frequently asked questions about Snowflake SQL. Understanding these will help you write efficient queries and avoid common pitfalls. To recap, Snowflake SQL offers powerful features beyond standard SQL. Efficient filtering relies on clustering keys, window functions are essential for analytics, and always be cautious with destructive operations. Use time travel as a safety net. Thanks for watching. The full article and code examples are covered in detail at TheCodeForge.io.